Hello. So let's start with day 4 for Leetcode. Let's quickly get into the problem. So, okay. So we go through the problems tab and we um, move to okay, 12. Okay, yet another string problem. Okay, another medium string problem. And let's begin uh, reading it. So it says parenthesis string is a non-empty string consisting only of the left parenthesis and the right parenthesis. It is valid if any of the following condition is true. It is just a simple regular bracket, left and right. It can be written as AB, left with A concatenated with B with closing bracket. A and B are valid parenthesis strings. It can be written as opening bracket A, closing bracket, where A is a valid parenthesis string. Okay. We're given a parenthesis string S and a string locked, both of length n. Locked is a binary string consisting of zeros and ones. Locked is a binary string consisting only of zeros and ones. For each index I of locked, if locked I is 1, you cannot change si. But if locked I is 0, you can change si to either this or this. So we have to return if we can make a valid parenthesis string. Okay. Okay. The problem looks interesting. So to explain it, the problem basically says, um, so we statement, we have a non-empty string with only and this. So we have several examples here, like a string like this or a string like this. Okay, and then we have another string locked, which is of the same length. The locked string has only zeros and one in it. Okay, so we have string locked, same length, consisting only of zeros and ones. Okay. So now it says if locked is 1, we cannot change si. If locked is 0, we can change si to either parenthesis. We have to return if we can make a valid parenthesis string or not. Okay. So let's try to understand this problem a little more carefully because it seems to have a similar nature to the problem on day 3. So, so for a parenthesis string, there is this. Okay, first and foremost, we know that the zeros are free. So the zeros can be anything, and we have some extra conditions about what a parenthesis string is like. So it says that for a valid parenthesis string, uh, strings that satisfy valid parenthesis this is condition. So this works. So we can AB where A and B are both valid parenthesis where A is a valid parenthesis. So like strings like so this is our most basic parenthesis string. So let's say we add this, an opening bracket, and let's say we use another. So I have added this extra space for clarity. Another this valid parenthesis, the smallest one, and then we close it. So this, so let's put some numbers. This is condition 1. This is 2. and this is 3. So this satisfies condition 3. Condition 3 works and is a valid parenthesis string. Parenthesis string. So several other strings we have, like we can also have something like, so let's say this is A, and B is is this. I guess it's very obvious why B works, right? B is basically same as the third condition. So we can also have I'm putting spaces for clarity. So this is satisfies condition 2 and so on. So this is just the description of the problem, but uh, uh, we will try to tackle the problem. So one few things I want to clear. So in problems like these, you can actually substitute this letter with the number plus 1, and you can substitute this closing brace with the number minus 1. So for like the first condition, you can see that the if you were to take the the sum over the string after substituting them with the numbers, net sum net sum of a valid parenthesis string is always 0. So how we can verify this condition? So you can easily verify this. It's very pretty easy to verify. How to verify this? So okay, so this verification is kind of like an induction problem. So let's assume that we can already see it works for this, right? It's it for AB. Let's assume it satisfies. This condition is satisfied for mm, every valid parenthesis string. Um, yeah, let's just assume that inductively, let's assume that it works for any valid parenthesis string. This holds true. So we know that for condition what it holds true because we already put plus 1 and minus 1. If you add them up, it's 0. This is by definition it's going to hold because A and B are both already valid parentheses. So net sum will be 0. This is also true because A is 0, this is plus 1, this is minus 1. So we get plus 1 plus 0, 0 minus 1, net sum will be 0. Oh my god. Okay. So we can see that overall we have proven that for a valid parenthesis string it's always 0. If it's still unclear, please watch the video more slowly. I'm kind of explaining it in a little hurried manner, but yeah, if not, then you can just Google regular bracket sequence. It's the basically the same thing as this valid parenthesis string. I'm just elaborating a little bit as to how we can make this problem simpler by just using plus 1 and minus 1. So one of these conditions is always satisfied by any valid parenthesis string. Another very important condition for any valid parenthesis string is, or a regular bracket sequence is, that it never starts with an opening bracket. So never start with opening bracket. This is important. You can see that for condition 1 it's already satisfied by default, and for this and um, I mean you can see that like if you ignore condition 2, and if you were to use this, you'll have to basically use this and condition 2 and 3 to build your valid parenthesis strings. So you will see no parenthesis string ever starts with an opening bracket. For example, this the most smallest string is obviously not starting with any opening brackets. And here, as you can see, we made our A string by using condition 3. So the condition 3 also, like this string A, let's call it A complement. this string a complement and b complement. We have a complement also doesn't have an opening string, and b complement, which we made out of condition 3, also is not having an opening bracket. And if you use condition 2 on these strings, we still don't have an open bracket. So um, I'm going to say that intuitively it makes sense that it does not open or close with an opening bracket or closing bracket, but you can put some more thought to be sure like why this works. But I will kind of uh, we'll just go along with this assumption. This is a fairly like it's an approved, it's a fact that this works. So let's just go ahead with this. Now let's actually come to the problem. So our problem says key wherever this log string has one, we are not allowed to change the bracket. We cannot put with like whatever is given to us in the input, it's locked. It cannot be changed. But whatever has a zero index, there we can flip the string as we would like to. We can use the opening or the closing parenthesis, and we want to make sure that uh, whatever substitutions we do, we need to check if we can. There is at least one possible way to make a valid parenthesis. Okay, so for this sample, it says that there is a way to actually make it valid. So how they do it on the zero index, they flip it to this, closing at, and and for the fourth index, they also flip it, so we get three. Like these individually, they are all regular, like they are valid parentheses, and overall also is valid. So let's start thinking what we can do for the problem. Okay, so this is already satisfied. This cannot be satisfied. I said you cannot have an opening bracket. Well, and it's also single lettered. And yeah, one more thing, I think, which is very obvious, that if your string length is odd, then there is no way you can have this valid parenthesis condition, because you can never get a sum zero. This is basic maths. So that is a simple, easy condition. Okay, so what can we do to tackle a problem like this? So obviously the ones are fixed and there's nothing you can do about those. And well, we also need to make sure that we can make regular brackets out of everything. Let's first think in terms of whatever is fixed. Whatever is fixed. So, okay. So, so one very obvious thing I believe we can say. Say suppose we have some. I will use x. X to represent. I will use. Okay. Let's just do one. So one means that it's locked. It has some value. Either it's an opening value or it's a closing. Sorry, I don't mean value. I mean it's an opening parenthesis. It's a closing parenthesis. So one means it's fixed. Let's pick a string like this. The log string is like this. Sorry, there one more zero. So we know this the leftmost one and the rightmost one have something, some value. We don't really care about this. This whole string, right? This whole string is even in length. It's 4, and for any uh, even length string like this, where we have the freedom to choose any character, we can very easily get an balanced, like valid parenthesis. How? So for 0, 0, 0, just do use two opening parentheses, use two closing parentheses, which is also the same as using two plus ones and using two minus ones, right? So we have this covered. So can we use this fact somehow for for solving the problem? Can we use this fact somehow to solve the problem? We also know for problems like these, if we were to like, we also know that since we need to get an effective zero, every opening bracket needs a closing bracket at some point, so that every plus one can be reduced to zero. Like subtract, it can be made to zero. So every opening parenthesis needs a closing parenthesis, correct? So now with the opening parenthesis, okay, we have a lot of things to consider. Hmm. What if we did the traditional uh, so there is a traditional way of checking if the string is like for any kind of parenthesis string, there is a traditional approach to check if it's a valid parenthesis string. Well, one way is obviously using the plus minus ones, and just checking for these conditions. There are nice ways to check this condition. One way is to actually use a stack. There is a stack approach that easily allows us to check whether it's satisfying this condition. So the stack approach basically goes like the stack approach for checking a valid string go is one push if current character is then just push it on stack. If it is, then check for these two conditions. If there is on top of stack, then just pop it. If stack is empty, then return false, invalid parenthesis. So I think it's very easy to check how this manages to check out both the conditions. So uh, the second condition is always checked by the condition 2 of part 2, that if the stack is empty, then we cannot have a opening bracket, which means when the stack is empty, that means we have gone through some strings and they have all turned out to be a regular bracket string. So together, like whatever string we had gathered so far, it was a regular bracket string. So whatever the next regular bracket sequence that is starting, like the next valid parenthesis that is starting, I'm using them interchangeably, regular bracket sequence and valid parenthesis. This this letter cannot be the first letter of such a valid parenthesis. So this is checked by condition 2 of 2. This as well, as I said, for every opening there has to be a closed closed bracket. And why does immediately popping this work? It's very simple. The reason why immediately popping this opening bracket for any closed bracket works is because we basically, through this stack implementation, we are basically doing these conditions only. Like we are simulating exactly these conditions. We are basically to say, okay, so to put it to explain it in very simple words, you see, it has been said that a regular bracket sequence may contain another regular bracket sequence inside it, like as you can see here, a and b are valid parentheses. So this is one case, and another is that the valid parenthesis is inside another valid parenthesis. So you can see that this, if you omitted this a, we get our we get this simple valid parenthesis. So we can see that there is a valid parenthesis inside valid parenthesis, or there is a valid parenthesis at the same level of the other valid parenthesis. Here a and b are actually at the same level. By same level, I mean that they are not they are not inside another, like they are not, they are relative to each other, they are at the same level. At the same level, I mean, like there is nothing like this, because if this happened, then this outside opening and closing would be at the same level as A. So if you like, you know, there are several ways to represent this thing, but you can use something like depth, where each opening bracket increases the depth and each closing bracket reduces the depth, which is basically the same, plus one minus one. You know, all in all, it's the same thing. So the reason this stack thing works is because it goes from the deepest depth. You know, it verifies the deepest depth RBS is valid, like deepest depth uh, string sequence is actually a valid parenthesis, and then it, you know, just goes from inside to outside. So it does exactly what we are trying to do here, just in a more, in a better way. So if this explanation is not clear, you can actually check this approach up in Google if my explanation wasn't clear. Now I'm thinking if I can use this in some way, you know, some modified version of this approach to solve this problem again. So we need, let me do some internal thinking to actually, you know, clarify if this is actually possible through this. Ah, hmm. Okay, so hmm, or maybe we can combine this, you know, this approach I discussed earlier, where we put, where we substitute a complete RDS for all the zeros. Maybe we can do something like this as well. So we need to see if it's something that we can manage together, you know, merge. So maybe let's use paint and, you know, try to draw some cases and maybe use those cases to figure something out. If it's a problem like the one we did yesterday, then again the formula will be same, trying a bunch of different inputs, gathering a common, you know, pattern, and then generalizing it to the solution. So I really hate to do this, but I think we'll have to just try some test cases and hope that we can gather something out of it. Okay, so I will not use 0, 1, 0. I'll just simply represent the zeros as question marks and the fixed brackets with like just the fixed brackets. So let's like take a random test case. Let's pick something small. So like one advice that I did not provide in the third day video was that if you are going to, you know, try out some cases for problems like these, you should first start with something, some input size which is small, which is like not, which is definitely not big, like it's sufficiently small but not too small. Like it shouldn't be too small that the cases are very obvious. So maybe something in this problem, maybe taking a string of length 6 or length 8 would be a good way to start off. So let's start off. So I'm just going to place some random question marks because really I don't have any idea what will our final solution look like. So let's say we have this. Okay, this is a 6, you know, 6 length string, and we have to figure out whether we can make a regular, we can make a valid parenthesis or not. So yeah, it's quite obvious that we can see what we can do. Like we can turn this into this, right? So I think this is not a very uh, wait, let me just first make a save of this. This is day4.png. This is not very big. Let's pick like size 8 or 10 to get some better idea. Okay. Hmm. Size 8 or 10. So, like, something like an odd length maybe. This is for size 8. Let's do this. And like this, I guess. Maybe. So we need to check if we can make this a answer, or maybe let's change it up a little bit. Maybe add something like this. Oh, okay. One more thing. We know that the number of opening brackets and the number of closing brackets is also fixed, right? So for a length 8, we cannot have more than 4 opening brackets. Like it's not possible to have more than 4 opening brackets, because if we have more than 4 opening brackets, because 8 is like 4 plus 4, so we need plus 4s and we need minus 4s. If the quantity of plus 4s is more, like we add one more opening bracket, then we cannot have as many negatives negative uh, as many closing brackets. And the opposite is true as well, that we cannot have more negative or like more closing brackets against opening. So opening and closing bracket what must be equal, right? This is almost, it's a necessary condition. Now next what we can do is, huh, so if we have to ensure that definitely there is opening and closing bracket should be the same. So like for the even question marks, even question marks. Hmm. So I'm trying to think a little bit. 20 minutes gone. Let me think a little bit internally like what we can do about it. We have this sequence. Actually, it's quite easy. If we can put closing on all of these, and this will work. Hmm. Question. Well, I did not check the constraints though. Like that was stupid of me. But yeah, I expected this to be 10 to the power 5. Hmm. So what can we do with the question marks? Huh. How about if No, but if it did that, there could be some problems. There could be some problems. Huh? How about how about how about let's approach the problem from a different direction. Okay. So there is like a group of closing bracket sequence, like adjacent group of closing bracket sequence, something like this in a row. And maybe we have some, zeros, basically question marks before these brackets. So we need to remember that question marks are very flexible, right? Oh, wait. Actually, but mm, that approach may or may not work. Actually, that approach might work as well, but I'm thinking of something very stupid and funny actually, but uh, hmm, whatever we do, we definitely need to make sure this condition, these two conditions are satisfied. So obviously the string has to be even length to start off. If it's not even length, there is no way that we can do anything. But also we need to make sure that this condition never happens. Never starting with an opening bracket. And these kind of problems are so hard to just, solve on notepad or on a paint because I don't really get the ideas unless I'm using a pen and paper and thinking about it. Okay, let me think internally a little bit. Question marks are there, so I'll open them out there. And we want to couple every closing with an opening bracket. Hmm. Hmm. Pretty sure I've seen this problem before somewhere. This is not the first time I'm trying this problem. Ah, that sucks. From the start, from the start. If I had a string already, or huh? Yeah, so if I had a string and we would be using the plus and minus one logic, then we could simply change, we could simply substitute plus one minus one for the corresponding positions and check if at any point the string's minimum values goes less than zero. So if it did, then the answer would be impossible. Because as I said, because if any point the sum goes less than zero, then basically that's the same as this happening. That's the same as uh, string the sequence starting with an closing bracket. So what could be a good way to do this? Mm, closing bracket count must be equal. So we want to make sure that our sum never goes below zero, obviously. And hmm, actually, how about we do something in a greedy like fashion, but it's not possible to do something in a greedy like fashion, right? Because hmm, so if we originally check the sum, with whatever ones that are locked, we originally check what sum we have, and we need to make sure that the prefix sum never goes below zero. The prefix sum never goes below zero, right? Hmm. Okay, how about we do it in reverse from backside? We know this whole thing has to be zero, right? And we know that this definitely has to be minus one because the starting bracket cannot be an opening bracket. I mean, cannot be a closing bracket. So this has to be a closing bracket. So we know that this has to be minus one no matter what happens, right? Like whatever is placed in this x, the last x, let's call it x underscore l. X underscore l needs to be equal to this, and let's say this is x underscore f. X underscore f needs to be this. This is guaranteed. So if we go in the reverse direction, we know sum equal to zero, and we start in iterating in reverse direction. So at least when we are at first we are at the last position when the sum is zero. So we move to last position minus one. So now we know we have x underscore f. We have a bunch of x's. We have this, and next sum equal to plus one. Like this prefix has a sum of plus one. This prefix has a sum of plus one, right? Now this prefix, if it has a sum of plus one, and we want to ensure that hmm, actually I think I might have figured out what I have to do. Hmm. But I'm not really sure. But I think I have it figured out. No, no, I don't really have it figured out. Sorry, no, not really, not really, not like that. Okay, there are a few things that we can do actually. Yeah, right. We can do a few things. So, few things that we can do is we can basically take out the minimum values. Uh, Something that we can do is uh, there's a lot of jumping around happening in this problem, but let me try to clarify this. So if we have something like this in our input, like these four things are fixed, we know this whole thing is equal to minus 4, equal to minus 4. So the prefix up to this has to be equal to plus 4, right? Plus 4 or greater than equal to plus 4. This is like guaranteed. This is guaranteed to us. So, right. So if this happens, we know we have to get greater than equal to plus 4. Okay. So if we go through the first few set of these closing brackets, we know that the prefix before that has to be greater than equal to that much amount. And and we have mm, we have um, uh, nothing is coming to my head for this problem. Hmm. Left and bunch of question marks. And a question mark is left. Several of them is left. Oh, oh, okay. Okay. Now that I think about it, the first and the last character of the string is fixed. There is no way we can do anything about it. So if between any two known characters, if between any two known characters, let's say let's say I have let's say I've calculated up to certain length of the string, and I know that I've calculated, let's say string length is 10. I've ensured that my that up to length 5 everything is okay, and from length 6 to length 8 I have 3 question marks followed by a known character followed by a known character. So in these cases, how we can deal with such problems, how we can deal the cases. So if everything is fixed in my stack, I will have a bunch of, you know, opening parentheses, right? I will have a bunch of opening parentheses. So if I have a bunch of opening parentheses, I have a bunch of opening parentheses. Hmm. Bunch of opening parentheses. Excuse me. Excuse me. So yeah, I think I'm overthinking it too much at this point. Maybe like, hmm. Oh, okay. I think I know something that we can do. So, okay, how about we do this? Say that this input. Let's write this input down effectively. What this input means. Okay, so let's take a text box, paste our input. So this is the same as question mark. This question mark. This question mark. Question mark. Right. This is what it is. So my claim is okay. This is not the kind of input I'm looking for. So like my let's say our inputs were like this. So, okay, so some arbitrary input. So what if we just did the stack approach and we just popped some of the characters as they come and go. Basically, we don't do anything with the question marks because we don't know what we are going to place with them. But for whatever we know, we use this stack algorithm and we just shorten this original string down to something more comprehensible. So like in this case, if I had to rewrite this, uh, what is happening? Whatever, I don't know why was this not working. So uh, so what we can do is uh, we will pop this and this, then these two will also get popped because we have this two opening, two closing. Then here we will pop this and then we'll pop this. If we are able to just this got simplified to something like this. I don't even know if this is so. If we were to simplify our strings in this kind of manner, then if we look at the final appearance of the string will look like as if there's a bunch of question marks, there's a bunch of continuous opening brackets, then a bunch of question marks, and a bunch of closing brackets, and so on. We will see this is the kind of sequence we'll get, and I think this is okay, right? Like we can do this. We can consider that we had some kind of final sequence where this opening bracket was associated to this one, this opening bracket was associated to, like this inner one was associated to this one, this uh, opening was associated to this one, and so on. Like whatever stack algorithm assigns us the opening closing pairs, we can approve them because we just want to know if like we assume like for those brackets the pairing is fixed. For rest of them, if we can still manage to assign them in a way that gives us a valid parenthesis string, then the ones which we have already considered, they will not invalidate the whole string because their pairing is already fixed. So we can do that. So Why we can do that? Because there we have already paired some of the opening and closing brackets for our convenience. And in the pairing, as I said, if for uh, each opening bracket there is a closing bracket at some point later on, then it's the same. The valid parenthesis string is satisfied. That is also one of the ways of saying that our valid parenthesis string works. So for some openings through this, pseudo stack implementation, like pseudo stack check, we have already assigned them some of the closing. And so we have already assigned like some of the opening and closing this. Now what we can do is for the remaining string will look like something in this kind of pattern. This kind of is what our remaining pattern looks like. So now I think it's quite simple that what we can do is, so for the first set of question marks, let's say we have a bunch of closing brackets here. So it's, I think here we have only one, but let's say suppose uh, we had, let's say, four. So it's obvious that we needed four question marks before as well, right? Or we needed four fixed these to match with them. So since this is like, I'm assuming this is like the very first sequence of question marks, so obviously there's no fixed opening brackets before this. So these question marks should definitely be enough to mitigate these, like to remove these remaining closing question marks. We should at least have four or more. If we have three or less, then that will just not work. So in this way, this first set of fixed brackets is done, right? What if our first set of fixed brackets was instead this? Then what we could do is we could just not worry about we could just not worry about these. We could just push them on the stack and just continue with our algorithm and just not worry about it. So we just need to check when we are getting the close brackets. Whenever we are getting the close brackets, we need to just check at that point. We don't need to worry about the uh, opening braces. We just need to worry about the close brackets in a way to say. Okay, so we need to only worry. So we are kind of going. We are framing some sort of uh, approach one. This wasn't really any not valid approach. We were trying to cook something with this, but we didn't come up with anything at the end. So we have this approach one, right? Here we are thinking that first use stack algorithm and match whatever fixed pairs of we can. Then our string will have question marks, continuous this or this, and question marks again. If we get a bunch of, we simply push them on stack and do nothing. If we get a bunch of, we will will pop them, will pop them will pop them using question marks or fixed on stack. So if we use this approach, after using this approach one, if if our parenthesis string is still valid, like at any point we didn't reach this condition, we didn't reach the condition 2. If using this second stack implementation, we never hit this condition 2, like the opposite of the condition 2, then 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 our final string will look like just bunch of opening bases and question marks, right? So obviously this time we have to just do the, like we have to run through the stack algorithm again, and we have to this time use our question marks to pop all these opening brackets, right? To pop all these opening brackets, like we are greedily doing it, we have to do it. So we are basically running the second stack implementation once again, but this time we are trying to clean all these opening brackets. So after applying this logic, this same stack logic approach, one repeated on this, we are just now left with only question marks. Because if we assume that everything worked well, we were able to pop all these opening brackets using the question marks, then we are just left with a bunch of question marks, and for this we just need to check if this is even length. Just check, just check even length, and that's it. Just check if it's even length, and if it is, then our solution works, because we made sure that at every point, for every opening parenthesis, we were able to assign a closed parenthesis without breaking the structure, like without violating the condition 2, uh, without violating condition 2. But I think my approach so far, like whatever I spoke, probably did not make sense at all. Like I was speaking in very confusing terms, and if someone was watching, they are also probably very confused. So let me try to put this together, verify if what I said seems to work, and put this into something cleaner, because what I just said and whatever approaches I came right now with, they seem very dirty. They don't seem like very turbid. Like they seem very messy. They don't seem clean, and we could run into some problematic errors, some logical or maybe even implementation errors. So whatever I said probably has a more cleaner way of being worked out. So let me like think a little bit more. Okay, so what I said first was we will use this tag-like approach, which we normally use to verify the correctness of a valid parenthesis string, and we will just at first, whatever we have this kind of uh, string, right? Some random kind of string, we will just use the stack algorithm, and we'll try to use the fixed characters to nullify these kind of uh, pairs that we are getting, to nullify potential valid parenthesis, potential smaller valid parenthesis that is already in the input. In this way, any kind of these valid parentheses that are already in the input that we can form, we can take them out. Then I said, if we do this, we are left with a string where we have a bunch of question marks, some contiguous opening, some contiguous close. So now I said, all right, we have some contiguous opening and contiguous close. So now we need to do something to make sure that the contiguous close brackets are dealt with. So next, we ran this approach again and we made sure that the contiguous close brackets are definitely like they are not screwing up our condition our condition of in short in short uh, to summarize uh, in the first condition I made it a point that this stack algorithm will make sure that we never have these kind of uh, adjacent opening and closing parenthesis sequences after we have run it through this stack algorithm first time. Since we don't have these kind of structures, we are definitely not going to have, we're definitely going to have a structure like this. If it's not clear why, then you can just review through these three steps and you can check it out for yourself that it's definitely going to work out like that. Because all the plus ones, okay, and to explain it in a better way, all the plus ones that could have been all the plus ones that could have been paired with minus ones without any question marks in between them have been paired, right? So now whatever such parentheses we are left with are the ones that did not get paired up because some question marks ended up following them. Some question marks ended up following them. So, or there were some question marks previous to them, so they did not get paired. So now what we do is we run through this algorithm again. This time we make sure that for all the fixed closing parentheses, we either use the question marks or we use uh, what we should say. We use question marks or the fixed opening characters that are already on like top of the stack to nullify them. And if we can nullify them without violating condition 2, then we will have another string structure that will just look like this with only opening brackets and some question marks which are following them up. So now again we will run the algorithm and this time we will pop these opening parentheses just in the same fashion that we did with the close brackets, leaving us with a string with only question marks and for us to check that if it's even in length. Now this approach that I said, there could be possibility that it is still wrong. One, there is a possibility this is correct, but this has a better way, or there is a better way to actually solve this idea. So it's already 1 hour. So what I'm going to do is I'm going to approach this problem a little bit later. I have some stuff to take care of, and I'll pause the video and then I'll continue from there. So you could say that I'm leaving the problem for the time being, and I will think on it again after I'm done dealing with the stuff. So just a quick pause. It won't make any sense in the video because it will just look like I paused and I continued again. So I'll come back in a bit. Okay. So I'm back from my stuff and let's continue thinking about the problem. So yeah, so as I said, in this problem, uh, we were following some steps that were it seems to be like getting a bit complicated if we keep following this line of thought. So let me think again what we can do and if this is the only way to go about it or maybe there is something better that we can do to confirm the existence of our parenthesis in this condition. So yeah, so certain characters are fixed. We cannot change them. Rest are interchangeable as we want them to. Okay, and as I said, we want to pair the opening and closing brackets, right? We want to pair every opening bracket with a closing bracket. And uh, yeah, so we want to pair every opening bracket with every closing bracket. And we were trying this approach of stack algorithm. I think I'm going complicated somewhere. I think whatever I thought so far may work, may not work, but it's a simple lead code medium, and I think I'm really overthinking this problem too much. Although the acceptance rate is quite low, it says 38%, it's right around one of those problems that I could solve or I could miss. It's that kind of problem. Acceptance rate. Let me actually refresh it. Actually, I've not refreshed this page for a bit, so let me check. What's the acceptance rate right now? And it says 40.3. So yeah, so it's not so hard as I'm thinking. Okay, okay. So what can we do? What else can we do about this problem? Hmm. So we thought of several things, and we want to maintain the parenthesis thing, and we want to make it a little simple to implement as well, because my current idea seems like it will take several rounds of implementation logic. So hmm, hmm, let's use this current approach to maybe find a simpler approach. So first we did, wow, overlapping stuff. Okay, not a problem. First we did was just run the stack algorithm and pop the pairs that can just match right off. Like they can match right away. Just pop those. Then the next step was, so is there anything we can take out of this approach? This switch. So like in a pseudo implementation, like pseudo code fashion, it will be like uh, so approach sorry, approach one is just a moment. Yeah. So the pseudo code is like if current copy. Yeah, so if current, I mean, it's the same as this approach. Okay, not pseudocode, but um, like let's call it approach 1.1 because it's the first iteration of the approach one. So we do basically exactly this, but so A is capital. But we also do this for question mark. Then just push it on stack. That's our first approach. What with this, we'll be able to pop some of the we'll be able to pop some of the characters, or if stack is empty, if there is a question mark on, then just pop it. if then just push it to the top of push it to the top of the stack, and if it's empty then return false in valid parenthesis. That's our approach one for this. Then subsequent iterations, like the approach 1.2, is to we get a string with just either consecutive positives or consecutive negatives. I mean consecutive opening brackets or consecutive close brackets. So now we try to handle the case for consecutive close brackets. Consecutive close brackets. Do we actually need to do this if handling the case for consecutive close brackets, or can we do something else? Can we do something else in this case? The case for consecutive close brackets. Hmm. Consecutive close brackets, use the question marks or use the left opening bracket, whichever is on the top of the stack to pop it. Can we not merge all of these into a single approach? Yeah, now that I think about it, I segregated these things into separate approaches, right? I segregated these things into like step one of approach, then we did a second approach, then we did a third approach, and then we did a fourth approach. Can we not just use a normal stack approach with the question marks and also involve these sub approaches together? So like what I'm trying to say is, can we not do something like this? Say suppose our top of the stack looks like mm, okay. Uh, how should I put it? Let me just spell out the approach, then we can try to visualize how our stack will be. So approach possible. Okay, we use modified stack approach. One, this is the character. Then just push it on stack. Okay, don't do anything else. Two, if question mark is the character. Oh my god, I wrote a capital F. If question mark is the character, then let's just check some cases. If question mark is the character, if top of stack is, then just pop it. Otherwise, just push it on stack. So what I mean, if we encounter a question mark in our stack, the topmost element of the stack is basically an opening bracket, then let's just pop it. Like we are using we we turn the question mark into a okay. This is what we're doing. So we are basically making that question mark into a closing bracket for this opening bracket if it is the topmost element of the stack. Otherwise, we will just push it on the stack. If this is the character, then we have some cases. Okay, sorry, sorry. If top of the stack is or, then pop it. Else, if it is empty, then return false. So what will happen if we like, let's just, before proceeding any further, let's just think if we just do this 1, 2, 3 steps, how will our stack look like as it, progresses? So we see that, okay, so we are pushing, okay, so we are pushing this character when and where we are getting it. And if we have question mark as the character, top of the stack, then we're just popping it, which means basically you're turning it to closing bracket. Otherwise, we're just pushing it. If we have an opposite character, then we are we are we are opposite character, then we will need either an opening bracket or a question mark to pop it. Otherwise, that means the stack is empty, because in the stack we are only pushing the characters opening bracket and question mark. So the closing bracket is never a part of our stack. So obviously, if the top of the stack is neither of these two, it means it is empty. And if it is empty, that means we just need to return false. So right now, this is like there's no guarantee that this works. There may be like something more that I'm not like looking deep into, or I'm maybe missing out something which is a bit more in depth. But I'm just considering what if this was correct, then how would our stack look like? So I would say in due course of time through this process, our stack would our stack will try to remove these as promptly as it can, and it will also try to remove these as promptly as it can. So basically, it will try to remove both or by removing, I mean it will try to very quickly match an opening to a closing bracket and a closing to an opening bracket, like in the traditional stack algorithm. So, so we can let me take it back to paint. we can we can have either this or question mark in a stack. Now the question is, can we have both and question mark together in the stack? Let's try to explore this. Okay, so I believe, so let's say at some point we have, okay, so Let's go back to our approach. And sorry if you hear some sounds of chewing. I'm actually eating. I'm eating and solving the problem. So, mm, uh, so if we look at this possible approach, here we can see we are pushing on the stack whenever we find this, but here also popping this, we're popping the opening bracket if we get the question marks. So, um, okay, so this is not possible. Okay, this kind of sequence is not possible. Let's say for a moment this is possible, but our algorithm states that we have to pop an opening bracket for every question mark that appears. So how many opening we have? 1, 2, 3, 4, 5. So that would mean no matter what. So if we were to follow our stack algorithm, this would finally turn into just two question marks, right? Now that means for any kind of sequence where the opening brackets come before the question marks, either the question marks will survive or the opening bracket will survive. Let's check the other way around. Question marks and opening brackets. Now, can this happen? Is this a possibility? Is this a sequence that can happen? It can happen. It can definitely happen. We could have this kind of thing happen. But once again, if we are to have something like this following it, like a bunch of question marks following it, this whole sequence would then turn into either something like dot dot means a bunch of a repetition of this character, or spacing it to show the difference that this question mark came after the the first four question marks, like this. Oh, so if you look carefully, our final sequence would either look like a bunch of question marks followed by a bunch of opening brackets, or just question marks alone, or worst case, just a bunch of opening brackets, which means obviously not possible. False. Right. This is also false because you cannot have opening brackets at the end. This can be true, but we need to check and confirm. Can be true. So let's go back to approach and let's give it a little bit thought that are we going towards the correct direction? Can like we have to convince ourselves that our approach is actually correct. I just made up an approach that I thought is possible after basically merging all the sub steps that we were doing into a single possible stack like approach. Hmm. So just think about it. Hmm. Okay. Question marks are more flexible than either of the fixed characters. So in this approach, we are trying to use a question marks as soon as we can if there is a character on the top of the stack which is fixed. If we didn't do that, if we didn't like, just greedily use the question mark as soon as we had a fixed character on the top of the stack, would that be better or would that be worse? Let's think. Wait. Uh, Say suppose the top of the stack is this, and we encounter question mark. As per our approach, we should remove both. Actually, not both. Just remove this from stack. But what if we instead push question mark on stack and not pop the opening bracket? So now our stack looks like this. Would this help us in any way? Would doing this actually help us in some manner? To check if this would work, let's take up some examples and try to convince ourselves. So let's say question mark, follow it with a close bracket. So not possible in this case, right? Question mark, question this. What can we do in this case? Hmm. Okay. I think this is a counter test to our approach. The solution for this answer exists, but if we follow our approach, if we the, this is true, the answer exists, but if we follow our approach, we will end up with this. Our approach will give us this because, as I said, if a question mark appears, uh, yeah. So our approach fails here. Yes, because we will pop the question mark as soon as we see the opening bracket, and then we will left with two closing brackets. So our approach fails literally in the smallest test case possible, one of the smallest test case possible. Answer is basically this for this for this possible case. So our previous approach where we were, you going step by step, first removing, pairing up whatever we can pair, then first only using question marks for closing brackets, Then using question mark for opening brackets, that approach works for this case. So this is fail. This is a fail approach. This does not work. So now we know, just one moment. Uh, this is turning out to be frankly quite annoying. This problem. So at least we know that our initial approach was not correct. Because I guess, okay, what about if we flip this string? Now does the sub approach work? The sub approach. Oh my god! Now the sub approach fails too. My god! Now, oh my god! Both my approaches are failing on this test. So now, if we went by our original example, uh, oh my god! What the? So now, if we went through our approach one, we would after first iteration we would end up with the same original string because there is no pair matching happening after iteration 2. Wait, maybe this does not fail actually, because in iteration 2, no, it actually fails, right? Because what? Yeah, it will fail. Yeah, it will fail because in our approach we were first doing. Yeah, see, I wrote this. So if we get a bunch of this, we'll pop them using this on a stack. So uh, after iteration 2, this will end up like this. So this is also wrong. So basically, all the approaches that I've discussed so far for like 1.5 hours, my God, they are all wrong. So we need to think again. And we have a wonderful test case in our hand. This question mark this question mark this. These are some nice test cases we have. Critical tests. Man, bro, this is peak competitive programmer who is failing on a lead code problem. Wow. Wow, fascinating. Okay. Okay, so let's start fresh again with the problem. So what we can do now. So our approaches were both wrong. They were not going to work. Stack-based approach was not gonna work. No matter whichever bracket we decide to prefer first, we'll end up failing one of the tests. If we decide to pair the question mark with openings first, then this test case will fail. If we decide to pair with the closing ones first, this test case will fail. So we need to find something that is not dependent on us choosing what we will do with the question marks, like uh, fixing whether we will go with we will first assign it opening or we will first assign it closing. Like so, something else we have to do for the question marks. Mm. Mm. Okay, well, one property of a regular bracket sequence is, I guess, it does not matter which opening we pair up with which ending later on, as long as we pair, like, if we pair with this, then we pair this with this, then we pair this with this. So yeah, so the main idea is that every plus one should have a minus one after it. Yeah, everything should be pairable, right? That's the only key criteria that we need. So every positive should just have every positive should just have a negative after it, or we should be able to pair them with a negative. Uh, hmm. And we cannot fix that. Which which positives do we pair? Which negatives we just don't know. Right? We like choosing to pair something is going to be a problem. Okay. Okay. Let's think of it like this. Okay. Uh, we have, I think at this point we need a fresh paint file because this paint file is kind of littered and useless. So let's make another paint file. Okay. Okay. So let me first save this and rename it as. Well, you have days like these too. Like some days you just cannot solve a problem, no matter part two, part two. Cannot solve a problem, and you can either just go and look at the solution or just try it for a bit longer. I would maybe, in fact, there will be some days when I'll not be able to solve a problem and I'll probably go and look at it. But today I'm not really feeling it, so I'm probably going to solve this and submit it, even if it takes like a bit longer. Uh, in case if it happens that the but no, I think I'll preserve the whole video because it's important to have this. After all, like these videos are first and foremost for myself, so that I can review my problems and mistakes that I made. And next, it is for people if there are any who are watching this. So since I prioritize my own learning, so I'm going to keep this whole thing, even if it's going to be a bit long. Yeah. Okay. So we are kind of starting out fresh in some ways. So we can use this text file because it's just going linearly downwards. So what can we do now? So I'm thinking, let's say if we were going in reverse direction, from right to left. I'm just trying a different approach this time. So if we had something like, uh, sorry, we had something like, let me just, go. Imagine if we didn't find that test case and we just decided to go with this approach. Uh, then I would end up with a bunch of wrong answers, and I would just keep butting my head and thinking, why is my approach failing? So like, it's a rare thing, but it does happen sometimes that I get the approach completely wrong in these kind of problems. And the only way to verify that is actually to have a test case and put your put your logic uh, against that. So I was saying, if we uh, uh, what is what is going on? And so if we had something like this, if we are going from right to left, so and let's say somehow we are going from right to left, and all we have is question marks on ours. After like sorting out all like maybe after fixing some positions, we know that like fixing some pairs on the right side, we are left with these question marks, and we know that or let's just think like let's just think that this is a sample. Okay, this is an actual input sample. Okay, and we know that this right opening bracket is just followed by a bunch of question marks. In that case, we know that for sure we have to actually use one of these question marks to uh, close this, right? So we know that for such a case, we have to definitely close the opening bracket with a question mark like this. So this has to be translated to this. This is definitely happening, right? So at least if you were to go from right to left, and we kept on encountering a bunch of question marks and a bunch of opening brackets, then it's a given that we have no choice but to use that opening bracket for use a question mark to substitute this opening bracket for sure, right? Now the question is, what if we come across a closing bracket while we have our question marks? What do we do then? What do we do then? We came across a closing bracket. Okay, so now since we came across a closing bracket, uh, we came across a closing bracket, and we have just bunch of question marks, right? So, so what can we say? What can we say? What can we say about this, or can we not say anything about this? This is the kind of state we are in. Mm, is there anything that we can actually say about this? Mm, uh, mm, doing some internal thinking again. Oh, question mark is coming. I don't know what to do. Hmm. Can't really say anything to be honest. In a situation like this, because like these question marks could be used for something before, but we know that for sure that these question marks will not be used for these closing brackets. So at least we know that for sure. At least we know that for sure. And it's not getting any more ideas at all. It's the only way to like just like mm, how do you even solve something like this? Positives, negatives, too many negatives, too many positives. But and they could be scattered around as well. There's no guarantee that there's no guarantee that want the pluses to be as left as possible and the pluses to be as left as the openings to be as left as possible and the closings to be as right as possible. Hmm. So, wait, what if the rightmost closing, rightmost closing, the rightmost closing is matched with the closest left opening bracket? What if we do that? What if we do that? I mean, now we are just changing the problem to its most trivial form, matching an opening bracket with a having a closing bracket after an opening bracket. That's what we are matching it to. And we're trying something different now, some sort of greedy kind of approach. So like I'm thinking like a bunch of I don't know what am I doing, but like so like I'm saying match this rightmost opening to the closest left opening bracket and do this throughout. Just do this. Omit this, omit, omit this, and omit this. Then omit this and omit this. My god, I don't have better way to represent. Now it's looking even more confusing. What the hell am I doing? Let me space them. Yeah, like this. So we kind of we're doing this. Okay, we go from left. We go from right side to accumulate the question marks, and we also what did we do? Kind of like priority, like the priority of an existing character is higher than that of a question mark because the question mark is more flexible. We can pair it with anything which comes before it, right? So, like using kind of a greedy idea. What this will do is like effectively shift our remaining left opening brackets to as left as it can. Like shift them as left as it can. So uh, in some ways, in some ways you can say that uh, not cute. Yeah. So I think the problem is actually very stupid now that I think about it. So one of the okay, I'm seeing something now. So we will have some amount of opening and closing, some amount of opening and some amount of closing, and with this approach, what will happen? A lot of the positives will end up getting mashed. Uh, in a way to speak, we are just considering the fixed characters and checking. Yeah, we're just taking the fixed characters and like kind of copying it. Yeah, right. We are doing that. Sorry for the repeated interruptions. Someone or the other is interrupting me. Already this problem is taking so long and then I'm getting interrupted so many times. So, right. So the idea is to mm, put this. Anyways, I'm saying that the idea is basically to match the rightmost closing with the leftmost. Sorry, the rightmost closing with the latest, like the latest, like the opening bracket, which is very much like the closest left bracket, opening bracket to the rightmost. And if we keep doing this, if we keep doing this repeatedly, you know, if we keep doing this, what is the guarantee that this will still work? Wait, no, it's okay. I guess it is still fine. I think. Hmm. So so I think the approach goes a little funny. Okay, okay. So if we have some right brackets left and we are encountering a left an opening bracket, then we simply reduce the count of the right bracket by one. In case that is not the possibility, then we reduce the. Okay, I think the video is taking too long. So what I will do is, I will stop the recording for a bit and I will just solve it by myself. And then after solving it, I will put the explanation so that we don't make this video any longer because the video is too long at this point, and it might take me a bit if I keep recording. Like this problem is hard for me, so it's better that I kind of think by myself, sum it up, and then I'll just explain the approach real quick, and then I also explain the code because I think if I keep going on with this recording at this point, just let's never mind. Let's just keep going with it. I'll do something about maybe I'll just cut some parts and match, join the ones which are relevant, something like that. This video, maybe I'll release it after a few days. So, okay, let's go going on. So if I keep doing this, what will happen? I will match this with this. Let me just. What? Nice, very nice. Notepad glitch. Let me just remove these for no. Let's just get this. Not being bothered by a problem like this in a while now. So we match these two with these two. Then we try to match these with these. Then we come up with more question marks. Then we try to gather them. And I think this is just kind of, it's not, yeah, it's not getting into anything solid, I guess. It's just, it's kind of not very solid. Um, okay. I think, mm, oh my God. Wait, let me just pause the mic for a bit. It's just too much. Uh, Never mind, never mind. So, mm, mm, what's going on with this problem? What am I overthinking? Oh my God, my mom's voice is so loud. Uh, mm, yeah, I think this is now counterproductive at this point. I will. Okay, this is what I will do. So this is counterproductive at this point. So what I will do is I will stop the recording. I'll upload this recording because obviously I'm using it for my reference, and I will start a fresh recording. I'll start a fresh recording. There, I will start thinking about the problem again from a different perspective. I don't want to like get, this video is already pretty long, so it's not gonna be nice. So I'll upload the next part if I can solve it there itself, and I upload both the parts for myself. So this one's getting too long, so I'm stopping this one.